Hello, today's going to be a brief video lesson about solving linear inequalities. This is just like how we would solve a system of linear equations, except instead of looking for when they're equal, we're looking for when one has larger values than the other. Now, if you look at this in terms of common sense, we're looking for a value of x that we could put here and here, that in the end is going to make this a bigger number on the left than it is on the right. The way I'd like you to do this is to start with a graphical approach so you can understand what the question is looking for. So we graph first the line y equals 6 minus x, which is a line whose y-intercept is 6 and whose slope is -1. So we go down 6 over 6 to find the next point. The other line has a slope of 2 and a y-intercept of 9, so I cross here at 9. I can go down 2, back 1, or I can go down 9, back 4.5, just to show a slope of 2. And there's my system. Now, you look at the color coding, the first thing we want to do is to look at when they're equal, because we're looking for greater than or equal to. First, when are they equal? And it looks like when x is -1, they will be equal to one another. But then the next part is 6 minus x is the red line, and the question is when will the values of the red line be larger or above the values of the blue line? And so that's what we have to interpret. So the first thing we could do is we can actually use algebra to verify that x equals -1 is the point of equality. So notice what I did here is I just set up with an equal sign, not an unequal sign. And I got x equals -1, so there's absolutely no doubt that my graph is valid and my place of equality is here. So now the question is, should we choose x's to be larger than -1 or smaller than -1? And if we're looking at it from the perspective of when is the red line above the blue, or when is the blue line below the red, no matter how you slice it, you'll always get to the same truth. In this case, I actually highlighted the blue graph being below the red, but if you wanted to see it the other way, we could be looking at when is the red graph above the blue. Either way, like I said, we're referring to the same solution set. All x's need to be less than or equal to -1. In interval notation, the way we write it is x is an element of, that means can be any number from, -infinity, not included, all the way up to and including -1. So remember the square bracket says include -1. So this is just a fancy pants way of saying x is less than or equal to -1. Just to make sure that this is valid, I could pick any number that's smaller than -1, and this should be a true statement, because my answer suggests that any number less than -1, so it doesn't matter what I pick, whether it's -2 or -2 billion, I should have a true statement on the left compared to the right. So when I put in -2, which is less than -1, I find that on the left-hand side we get 8, and on the right-hand side we get 5, so this is in fact a true statement. That's all you have to do, and like I said, there's going to be a set of exercises in the web page and all that you can use to just to practice this. So it's a great chance to rehash how to graph lines in an efficient way, how to find the intersection of two lines using algebra, and then the new part is how do we use interval notation to describe all values of x that make the inequality true. So this is just like the work we've done in the past, with the one exception of using a set of numbers rather than just a singular number for our solution. So I hope this is helpful. Have a good day.